Okay, and now we should be live. Are we live? Let's see. Yep, looks like it. Nice. Oi. Then let's quickly see what kind of music to listen to today. God, it's always... getting the first song is always such pain because I do not know which one. Let's go with that one. That's a good one. I hope it's not too loud. Okay, no, it seems to be okay. Yep. Okay. Actually, just... okay, no. Microphone is okay. Let's quickly just tell everything on Discord that we are live. Wrong. Live. Okay. Then we have that. Good. Yeah, cables stuck a lot there. But yeah, today the capture card actually works, so I can code on my computer and stream from the laptop. Hey, no technical difficulties. Okay, then, what I did yesterday, I prepared. Holy shit, I actually prepared stuff. Yes. What's happened? We previously had this player tag function, which took the player entity and the struct and the target entity. In this case, like, all entities are just the same, so it works out, basically. I only plan on, like, attacking entities. If that changes, I have to restructure. But yeah. And what I did is... what it does is it just checks the player's attack if it's over the target's defense, because otherwise it doesn't do damage. And if so, then the defense gets subtracted from the attack, and then the value gets subtracted from the health. And then if the health is equal under 0, the target just gets placed into the wall. Yo! Yes, there's Joy too, behind the chat. Hi B, welcome. But yeah. If a target dies, it gets into the wall. But yeah, that's basically part of what I did last stream. But yeah. And then what I did with this player attack function, I translated it to assembly. This in specific is x86-64 assembly. So basically means any most modern desktop computer is x86-64 bit. Why assembly? Because it's fun. Like, I can take all of this, which looks like really complicated, and can dumb it down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14 assembly instructions, which in total is really, really simple. What it does. So, what we do here, we comment this out, and we still, in our player H, we still have our function definition. The thing is, this function is now defined in a .asm file, in an assembly file. And so what happens, we just say, okay, we have a global called player attack. Global means, okay, this can be accessed outside of this file. So here, so it can be done here. And player attack is just a label. It's just a name. It just tells the compiler, hey, player attack lives at this position in the code. They look so abstract for my monkey brain. All good, all good. I can explain. And then, by default, we have several things. I can actually open up Obsidian for that. Let me go to NASM for that. And yeah, here we have the registers. These are registers in the CPU. And here we can see we have RSI, RDI and RSI. If we scroll down to them, RSI and RDI, they're scratch registers, which means every time you do something with them, they are not expected to have the same value they had before. Like for example, if you do a function call, they are not expected to have the same value as they had before the function call. That's what scratch means. Preserved in this case is if you have a preserved one, then they will stay the same after a function call. Or the system expects them to stay the same, because this one is, for example, the stack pointer, one of the most important registers. This cannot... Like, if this one accidentally changes, bad things happen. Bad things happen if this one accidentally changes. You're the only one I know that uses Obsidian for docs. I basically just copied this into here. I just copied it from another website, but yeah. Oh, yeah. As you can see, RSI are scratch RSI and RDI, both scratch registers. And function argument 1 and function argument 2. So in x86 64-bit assembly, oh no, in 64-bit Windows they are preserved register. So if I wanted to do this for Windows, I actually needed to do other stuff again. I do that too. Nice. But yeah. If I do this on Windows, I actually have to change it, because it's expecting different things suddenly. But yeah. These are basically my function arguments, which we have here, like the entity, player and target. Player is also now also a pointer actually, because that makes it simpler, because I'm passing a pointer and a pointer both to just entities. So and entities are the same, so some math later just is easier. But yeah, then what I do here, let's go to the first instruction. You don't have to look at this, I'm gonna explain all this. So, move. MOV is a move instruction. We move something from one place to another. In this syntax, which is called NASM, the net wide assembler, we move into EAX. So first we say the instruction move, then we say the source, then we say the destination, and then we specify our source. Now, EAX is a 32-bit register. Our integers inside C are by default 32-bit, at least on Linux. So we want a 32-bit register, just because it's the same size. Next, we say, we need to decode this. So, what is this? We have a D word, it's a double word. I actually also have it written down here. D word is a double word, which means, so a word is 2 bytes. A double word is 4 bytes. Oh, shit. My laptop's battery is going down. I need to quickly fix that. There we go. Hey, yeah, it's charging. Oh yeah, my battery was at 5. My laptop's battery was at 5%. Oh god, that's bad. Yeah. But yeah, a double word, 4 bytes, 32 bits, in integer. Nice. So, we want to move a D word into EAX. Now, the first thing we want to move, like here, we see the first thing. That was close. Yes. The first thing we want is a check if the target's defense is smaller or equal to the attack, or the attack is smaller equal to the target's defense. So we move. I can actually also. Nah, let's keep the target. That's actually, yeah. Okay. Then, so we need both of these values. How do we get those values? We do that here. We move it into registers. We move into EAX and ECX. So, and we know attack and defense are integers, so we use D word. Next, we know RDI is our function argument for the player pointer. Then we say RDI, we want the D word living at the address at RDI, because we pass the pointer, so RDI contains a memory address. That's why we have to do these brackets. They designate we want to access the information that is stored at this memory address. And then what we do, which is even more wow, we shift it, or we add 12 bytes to the memory address. What does it mean? Okay, for that we have to look at our struct entity. Now it makes so much sense. Does it? Oh, there. So RDI, our player pointer. The memory address starts, let's say, at 0. Let's say RDI is 0. Our struct starts at 0. What's the first thing on our struct? The positioner. The positioner is size 8. Meaning it has 8 bytes in size. So it's from 0 to byte 7 we have our positioner. Next, we have our health. Also, or in this case, 4 bytes only, which means it's from position 8 to 11 we store the health. Or in that memory address 8 to 11 we store the health. Then integer, and then attack. Again, 4 bytes. And we know until 11 we store the health, so attack is stored in bytes 12 to 15. 12, 13, 14, 15, 4 bytes. D word. So, we start with the memory address at 0, which is the start of the struct entity, start of positioner. And then we offset by 12, and then we jump from the start all the way to attack. And that means now we're getting all the 4 bytes that are at this memory address, which is attack. It's a lot, but if you understand pointers and like how memory works a little bit, it will be easy after a bit, honestly, after a byte. But yeah, and next up into ECX, which is our next register. Like EAX, ECX, they are just like also in this case RAX and RCX. Also scratch registers. And typically, for example, in RAX you would return a value, but this function is actually a void function, so it doesn't return anything, because we are passing in pointers. We are passing in the pointers, so just the memory that we already have. We don't need to copy any memory, which makes it much easier. Otherwise we would also have to copy the memory address for the struct, and oh no. It would be weird otherwise. Okay. Brett Hagen, do it Rust, CLion. No! Fuck Rust. I look at Rust and it's like, what the fuck is that supposed to be? No. Okay. Yeah. As I said, EAX, ECX, just scratch registers that we can use however we want. And we use the 32-bit variants. EAX and ECX. Okay, and then here in this line we basically do the same we did over here, but this time instead of RDI we use RSI for the target and plus 16 to get defense. And yeah, then we basically have attack and defense in here. Then CMP, compare. We compare both values. What this does, it actually does nothing really. What it does, it sets flags. We have several flags, like a 0 flag, or let me actually x86 64 flags. There we go. I think that should be enough. Let's go to Obsidian and something odd has happened. Let's check source mode. Ah, okay, let's add some more. Yeah. There we go. I didn't have enough lines between, so it suddenly did weird stuff, but yeah. Like that, out of source mode. Okay, we have a lot here, but we have several flags. They are just called 0 to 15. These are the masks, so if you want to mask those flags, you would do these things. Then the abbreviations, and here the descriptions. So, carry flag. If we let's actually just go to the 0 flag. 0 flag means, hey, the last operation resulted in a 0. So if both values attack and defense result in 0, it sets a 0 flag. Because what it does is compare, basically, it just subtracts ECX from EAX and then checks, is this value now a 0 or is it above a 0 or under? Then we also have a sign flag. Yeah, it's Wikipedia links, goddammit. But yeah, now we have a sign flag, which means, did the value become negative? Because signed integers means it can be a negative integer. So, signed, unsigned integer. Let me just go here, like, signed integers can represent both negative and positive numbers, while unsigned can only represent numbers 0 to, well, for in 32, 4 billion. 4 billion something something. Yeah, here, like these values, you've probably seen these at some point. Like somewhere online if you've looked at numbers, but yeah. And what it is, what we check, okay, is the number that we now have a signed integer? Because that would basically hint at it's a negative number. If it's then a negative number, like if the ZF or SF is set. So yeah, we now have here JLE. Bit of a cryptic instruction, but makes sense. J, jump. We jump to a memory address, or label in this case, a label, which we specified here. LE, less or even. So if this comparison results in a result that says, hey, it's less or even, we just instantly return. And that is basically this line here. This line is these 5 instructions. Where we get the stuff, we compare, we check, hey, is it that? And then we return. And actually, that is exactly how your compiler would also do it. Like, your compiler would just spit this out. But yeah. Next up, if it's not, we then subtract the defense from the attack. And next, what we need the target's HP. So we basically just say move into EDX a D word, or the D word, like the 4 bytes that live at this memory address. Again, RSI for the target, and this time +8. Because position is 0 to 7, and then 8 is where our health starts for the next 4 bytes. And those 4 bytes will be moved into EDX, then the attack, or then, yeah, attack gets subtracted from our health, and then we move EDX, we know it's a D word, it's 4 bytes, we move it back into this position. Because here we actually can only, we cannot set it like we do here with like instantly like set it, hey, because we can't just say like subtract from like RSI +8 ECX, it doesn't quite work. So we gotta do it in this a bit more roundabout way, but still works. Next up, we don't do a compare, because here we again do a compare for like less even, like we do up here, right? But no, we do test. What this means, test checks these values against each other, or well, just checks EDX, and if it if it returns that it's the sign flag or 0 flag is set, we jump over this and jump to return kill. What this means is surprisingly straightforward. Yes. That's assembly. It's completely like straightforward in my opinion. That's why I love C and like next like assembly. It's like you look at the code, you know what it does. Like you know what it does on a basic level. Like other code, sure, you can also look at it and say, yeah, I know what this does, but here you actually know it at a basic level. Oh yeah. Okay. Next up, because we want to, if the target is health is under 0, we want to kill it. How do we kill it? We basically put it inside of a wall. We put the target in a wall. So the player cannot interact anymore, and the target, and if the target is at this position, then yeah, it also can't do anything. But yeah, we do here, we move 0, which is a D word, in this case kind of bad, because like we're wasting a lot of bytes on a 0, like we're wasting 32 bits just to write it on a 0. But yeah, we move this into RSI +0 and RSI +4, which is our position, because our position starts at 0, and if we go into our position we can see it has 2 integers X and Y. X starts at 0, goes until 3, like 4 bytes again. And Y starts at 4, goes until 7, 4 bytes again. So in 0 and 4, we move 0. But if you actually want to be smarter, the thing is, those 8 bytes, like we're writing to 8 bytes, those 8 bytes, they are stuck together, they are always next to each other. So, what we can do instead of moving 2 D words into consecutive positions, we can move 1 quad word. We can move 8 bytes directly into this. Then we can also get rid of this. I just did it for a bit more transparency. But yeah, now we move 8 bytes of 0 into RSI, which is setting the whole position to 0 at once. And if you did that, you are as good as GC's, like this is what let me get a scratch file. Just give me a damn text file. Yeah, sure, Markdown. So, if you do this, like you often do like GCC, like main dash, like 01 for example, or 02, 03. If you do this, you are as smart as dash 03. Well, 02 in this case also, but yeah. And like, I'm not just making stuff up. I can show you. I can show you in the compiler explorer. Here we have our code, our player tag function, the exact same. I also put the structs in here because otherwise it doesn't work. And you can see here, dash 02 results in this quad word pointer, like moves the 0 into this. Don't be confused here, like with the stuff looking a bit different, like quad word pointer or stuff. That is just different syntax, but it's the same. Like we can't do NASM here, so yeah. But it's basically, it's completely the same, yeah. We do have Intel syntax, because otherwise, if we don't have Intel syntax, we need to look at this mess. And like, I don't wanna look at that. Like, this is AT&T syntax, and I don't like it. I like Intel syntax. Because it just looks much better. But yeah. Here we can see it's exact thing what dash 02 would do. Dash 01 would do it the way it was before. And dash 00, no optimization. I don't know what it's doing. I cannot tell you what it is doing here. This is weird. So, yeah. If you want to learn assembly, don't do 00, do 01. Because it's so much easier. Like, I will not even try to dissect what is going on here. Like, it puts it into RBP, which is like, RBP, if we look, RBP is something stored all values of the stack. Like, why are we doing this? Like, it makes no sense. We're using RBP to like do stuff. It doesn't make sense in this case. And then we also use REX for some reason, and it is... We just waste so many cycles. Don't use 0, use 01. It will make much more sense. Yeah, how many browsers? Only 2 browsers, okay, good. Oh good. Yes. Okay. And again, here, like, what happens actually if the HP stays above 0? It just goes to here. Like, if this jump fails, like this is a jump with a condition, this conditional jump, if it fails, it will just continue to the next instruction, which is this. It will ignore this, because this is just a label. This is just like pointing to this bit of stuff. Like, it's just a label, it's just a name. It doesn't mean anything. But yeah. And then it returns. Like, red is just return. And yeah, that would also be here here we return early, but we don't have a return here because we're in a void function. So yeah. I will comment this out again, actually, because otherwise it will conflict. But, what I also had to do in my CMake file, these are like, I had to do this stuff. I only understand it a little bit. So what we do here is any.asm file inside of our source directory. Any ASM file gets put into the list of ASM sources. Then for each ASM file, or no, next is we set ASM object as variable, but it's empty. Next, for each ASM file in our list ASM sources, I hate, God, this is so annoying. These tooltips. Yeah. You know what, let me tooltip. There we go. Yeah, now it... Okay. Yeah, for each ASM file we get the file name, so we just get the name of the file without its ending. Then we make an obj file in our binary directory with this name. So because we first have to do an object file. When we compile, you first first make object files, and then those get made into the actual binary files. But yeah. Then here, we have a custom command. Our output is an obj file. This one here. Or yeah, the current obj file that we had set. Then our command is nasm in our format elf64, just for Linux. Then our asm file from the sources. -o, we want an object file. And then our object file name that we got from here. Then it depends on asm file. Like, if there's no asm file, doesn't work. And then we just do a comment. Like, it just like comments in, like, if I just, for example, say build no, it actually okay, no, it actually doesn't do anything. Interesting. I thought it would like show the comments, but whatever, doesn't matter. Whatever. Next up, yeah, here we to the list of ASM objects, we append our obj file, and then it's just a for each loop. Then we add our custom target, ASM objects, this time written in not capital, but lowercase. Different. It's can be confusing. We add all of ASM objects, and it depends also on ASM objects. Then we add our executable, which is just our sources files. And then we add dependencies, our ASM objects, and then we link the ASM objects to our executable. So straightforward. I do not like building systems, but at least it's more straightforward than, like, if you go through the file, it is quite straightforward. But yeah. And next up, I want to make more things into assembly. yeah. So, we have this comment out, yeah. We here have our function, and we can check here, we are also using it correctly, we pass the pointers into it. Thing is, next, I want to make this into an assembly function. Now, new challenges. We have several constants. We use grid size and enemy amount as constants. So we gotta figure out. Turn C into assembly. Hi Buff. Hello. There. We gotta figure out how do we get our constants into our to be read inside of our assembly files. And next, how do we get, because this one is 3 positional arguments, or 3 arguments. Yeah, we can see here, and it is of type struct position. Actually, to have it not be of stripe, a type struct position, what we can do is we can pass the player's pointer. We go here, and yeah, and here we do this, and we pass the pointer. Then I do not have to say pointer here. The thing is, this one here is also already a pointer, but here we gotta still say pointer because we aren't putting all the enemies into it, because like if we did all the enemies, where can I install this game in terminal? Not yet. But yeah, like at the moment it's just, oh god, yes, just a moment, let me fix the code. Let me fix some code. Can I put it here, please? Where do we... there. There we go. I think that's the... no, that's the only issue. Yes. Here we have it, and of course it doesn't work in this terminal. Let me... right. Oh, whatever. There, CMake, yes. Here, this is currently the game, and it's currently just for me. But yeah. And I am dying, I have 1 HP, 0. There is no game over for the player yet. But yeah. It's also flashing like this because it's writing a lot of things. What are you using for coding? Yes. What I use is CLion. It's a JetBrains IDE. Yeah, and I code in C and also some assembly of it. Let me actually just make it full screen. Makes it a bit better. Okay, but yeah, I mainly code in C, all of this C code. And then also here some assembly with a lot of comments. But yeah. Okay, yeah. And it's quite fun. I'm mostly trying not to use things like ChatGPT. I do learn, like in the past I've learned with ChatGPT, and I sometimes still do, but mostly I just Google stuff now, or like I first try to figure it out, then Google, and if really I can't find out anything, I use ChatGPT, because last stream, for example, it found a bug that I just didn't think. OS, it's Linux. Linux Fedora. Can I, okay, let's see, does that work? Okay, no, I can't install NeoFetch, so yeah, I can't show you that, like, nicely, but yeah. But I use Linux because it is so much nicer for, like, programming, I think. And, I had a friend of mine, they had a Windows update and it bricked their computer, and when they tried to install Windows again it just formatted their drives, and I don't want that happening. So I am on Linux mostly. I do go on Windows sometimes for like some games that just don't work. But yeah. I do happily use Linux. Yes, absolutely. It's absolutely a nightmare. I might try Linux again. Yeah, definitely like go for it. But yeah. So, hopefully it doesn't end up taking half a month. Yes, that can happen. That is also kind of the Linux experience. I think a friend of mine recently also switched to Linux. She used Bazide. Bazide, it's this one, which is made for Linux gaming, basically. It's kind of its idea is to be used as like for like handhelds and stuff, but also desktops. But yeah, it works with like basically the whole Steam library, besides like anti-cheat stuff, like anti-cheat being anti-cheat. But yeah, the PewDiePie videos, they were also really cool. But yeah, I used Linux since like last year when I got my laptop, because I got that laptop just like for programming and working. And Linux on it was just a better idea. It didn't work at first, so I switched back to Windows. But within 5 minutes of being in Windows, I was yelling at my computer again. Like, and then I was like, nah, honestly, let's go back to Linux. Now I dual boot because some stuff, for example, like on my laptop, actually the stream is running from my laptop right now. But I am Windows because I don't want to deal with like my capture card and OBS in Linux. But yeah. But yeah, what we could do is, here, let's do this and this. And it's gonna give us some errors. Exactly, compilation failed. Let me make the text size here to like 10. So grid size, enemy amount. So what we just need to do is define grid size, I think it's 15, it doesn't matter that much though. Define enemy amount, 5 in this case. Wait a moment. Oh, error, implicit declaration of function player attack. Ah. Yeah, this is... This makes it a bit annoying, but we can just do this. Basically, we need to like move everything over, which is it's a bit odd, but yeah. Now it incompatible type for one argument of player attack. Wow. It's looking for everything, goddammit. Why is it still saying compilation failed? Oh no, because we're passing this, we can just do this. And here, okay, finally. Okay, here, we have our player tag up here, as we had it before. We are on 01, just to make it easier. And yeah, basically all is the same here. All the same, yes, yes. Now, player move. We have to push some values onto the stack. Means, next stream we should rewrite Linux. No. Yeah. So, what we have to do here, actually. Do this and... no weird scaling. Yeah. Okay, so... what we do is here... we push things onto the stack, meaning we want to preserve these values. We want to preserve these values because we are gonna use these registers. And RBX and RBP we can check, and the RBP is a preserved register. So yes, we do need to do that, and RBX also a preserved register. Don't use it without saving it. Yeah. That's what preserved means, like, you don't want to use this without saving it. So what we do is, we push it onto the stack, and at the end of it, like in any of our return statements, we just pop, and pop it back off. But yeah. Okay. So basically here into RCX we put RDI, and in RDI we put into RCX, and RSI we put into RDI. I don't quite know yet which of these ones is which. I would say yeah, because like this can be basically ignored for now. Oh, there. Why are we putting something into RDI? How is O2 handling this? Oh, okay, we are not gonna do this. I don't know, I don't think I want to deal with XMM registers yet. Yeah, no. How is O3 handling it? Also XMM registers and way more labels. Like, the more labels you kind of do, the more like harder you go on the optimization, the more labels it just likes to do. How does O0 look? Yeah, this is why you do not use O0. Because it just becomes a mess. Okay, let's try to decipher what the heck it's doing here. Okay, we move RDI into RCX. So our first thing here is our added position. And then we move RSI into RDI, which is our pointer to player. Then our current position becomes... But why does it become EBX and EBP? That's why we pushed these before. But why do we do that? Like, that doesn't make much sense. We could do a quad word. We could do quad word again in this case, honestly. And just move the first 8 bytes of it into just RBX. Yeah, then load effective address of... Wait. Okay, so we then get Wait, what? What? Computes the effective address of the second operand, the source operand, and stores it in the first operand. But these are already... We already have... Why do I need... If I already have the values in these registers, why do I need their address? This doesn't make sense. What the hell are you... GCC, what are you doing? Okay. Okay, here, so it makes our current position one. Our current position like a variable. It initializes it with our player position. That at least makes sense. Yeah, so RDI is our edit position variable. And then... But why? This I do not understand. Like, also, why is it shifts the bits? Like, it's an arithmetic. Arithmetic. Is it arithmetic? Shifts the bits as the first operand to the left or right. So right. So a right arithmetic shift by the number of bits specified in the second operand. Bits shifted beyond the destination operand boundary are first shifted into the CF flag, then discarded. At the end of the shift operation, the CF flag contains the last bit shifted out to the... What? Okay. Now that is just becoming confusing. Okay, because like I would handle this quite differently. Why do we arithmetic shift by 32? 32? That's an yeah, no, this is 32 bits. Yeah. Bits. We shift by 32 bits. And we do RCX. Which doesn't make sense. And then we add ECX and... Okay, I think I know what it might be doing. Because RCX... No, I don't know what we're doing, honestly. I kind of know. This is... Can I read on the other? Ah, god damn it. Let's copy this. Let's make... Let's just put it here for now. So this we can... Yeah, this we can safely ignore because we have it already. Okay, so I'm just gonna... I'm gonna do that, okay. Save registers. This is edit pause. And this is pointer to player. So the thing is, why do we overwrite RDI like this here if we have RSI already? Okay, no. Right, right, okay. So this here is this line. Okay, that makes sense. Let's quickly... But here it says this line is current position. What is RDI used for then? RSI move into RDI. Like, it's used for nothing. What? RDI isn't used anywhere. Like, this is a useless instruction. What? No, this is actually a what? This makes no sense. Like, honestly, it makes no sense. What? Yeah, here it also does like a call player attack. This instruction makes no sense to me. What the hell? Okay, and then it says this is the current position it's tied to, because no, we have moved the memory address RSI into RDI, and the memory address R is RDI into RCX. The thing is, we then do this. The thing is, we have pushed RBX. Like, RBX at this point is out of context. Hello. Hello, hello. We're currently looking at assembly code, trying to deciphering what it did here. Because, like, there is some sense behind it with this, like, arithmetic shift to the right, because what it does here is it moves the values from, because this here, because ECX has, there are values in ECX, which is the 32-bit register, and it moves them all the way into the upper 32 bits of RCX, so, which means the lower. Yeah, and then it moves EBP into ECX, which means it, because... Wow, what are you doing? Programming. In more detail, I have a C code here. This can actually come out again. I have C code, which I want to make into assembly. I have one of my functions, this player attack function, where the player attacks a target. I already have that in assembly. Currently, I'm trying to make the player move, which, sorry. Which, the player move function, which moves the player and also then calls the player attack. I'm trying to make that in assembly now, and I am having some problems understanding. Because what I'm trying to do is understand, I put it into Godbolt, which basically disassembles it for me. Or assembles it for me, and bro, you're crazy. Nah, no, this is nothing. But yeah. And like, overall, this is gonna be a game, that you can play in your terminal. Like, the @ sign is player and the X's are the enemies. And here you can see, like... Wait. Okay, I am not doing well. You can see my health is negative. I don't have a case for that yet. But yeah, if the enemies die, they actually... All the enemies are living in this plus up here. They are all living up here. Oh there. And they are not allowed to move out of here. Out of this plus. Oh there. Good, I'll just look where we use some of this. What? Okay, so this is these things. I will just ignore this part for now and go over to this, because here grid size is something important. Okay, it just puts those variables in here. Okay, so then it seems like because I have a standard.h file with like several constants here. But now because I don't think I can read this standard.h file in my assembly file. Like normally I think you could just do like include like just any file, honestly. Like you can just include whatever, and it basically would just copy this here. Like it would just copy it here. The thing is, the problem, this is C code, this is assembly. These defines would become it would become section data, oh god. How do you do this again? I gotta look into some other code. And of course I don't have any on here. Of course I don't have any on my desktop right now. There. Otherwise I could check again. NASM define bytes. NASM section.data. Let's see. Come on, just give me some example code. I just need to quickly... Okay, here I would then have to do enemy amount define byte 5 and grid size define byte 15. The thing is now, how do I read these in my other files? Because that's the problem now. Oh god. Let me look real quick. Okay. This is gonna be much more complicated, I think. Because otherwise I have to define these in like several define these in my assembly and in my .header files, and then I just copy this data, and that would also be annoying. Oh. Okay, you can also just do global. Let's just do this so I don't have to rewrite it there. Yeah, that is. Yeah, this is honestly yeah, I just gotta extern unsigned char. No, this one is enemy amount. And this one is grid size. Let me. Hey, you're seeing okay. Yeah, because I'm doing define by it, I actually got a 2 char. Which is funny, yeah. Because this is variable char, but the only reason it is that is because it's Wait, can I? Aha. Yes, because that makes it much nicer. Uint 8. There we go. 8-bit number. I would love if I got less. Like if I could do less. Yeah, but it's yeah, defined as this here. Defined as an yeah, unsigned char. So I sadly can't do smallest type with at least a given width. Okay. But yeah, really can't do. I do have int max and uint max here. But it seems like you can't really do squad type. Or S quad, not squad. Yeah, because of U quad and. Okay. So it seems like a lot of stuff is just defined here. But yeah. Ah, okay. It seems like he sadly can't like do a smaller than a U8. At least like with my current knowledge. But yeah, with that I can also I can include standard.asm or yeah, no, I'm just gonna make us like this standard.asm file. Oh no! Ah, goddammit. Let me do it again. But yeah. Yes. So like that is actually really nice because can just then also do in the face width and God, how can I type in the face height? Wait, interface width is 75. Wait, I can... In here I can do... so... Here I can save 2, 4, 8, 6, right, 16. So I can't do define byte because that is 75. 15 works, but no, I can. It's define byte. That's 8 bits. Yes, I can totally do this. I can totally do this. But now I actually don't know anymore what actually it is. I still have the clue here, but the value is now unknown. But yes, also let's like move this here, like up. Debug is actually, I don't think used anywhere. Yeah, no usage is found. Okay. Then just can do this. This is external, so it will just grab it from somewhere where it can find it. No, I would probably want to make this in an include file, because then if I make this in an include file, it will not be what will happen, it will not be assembled and compiled, because otherwise this would be like compiled completely, and then I would have this file here, but it would also be included in here, so I would have it double. But if I make it an include file, I can still include it here. Like I could even call it a whatever file. Like as long as it's a file that exists, it works. So I can include anything, and it just, like as I said earlier, what it does, it just pastes it in. But yeah. It pastes it in, so then that's here. But no, because other files are also dependent on standard. Like on standard.h on these ones. Oh god. Because instead of this, if I can just do extern and grid size, that would be God. Okay, I gotta. Here I would. I'm gonna get something to drink real quick. Okay, and I'm back. Huh.
You got the rest. Maury's in the building, so you know you're already dead.
Interesting, this section row data. Yeah, then also all of them is const here. Okay. So then I will just do my own player move for now. That might just be the best. I just did like getting all these goddamn constants. Yeah. But yeah. What I can do now is name this, make this an assembly file again, because now I do want this compiled, and I just do this extern grid size and extern enemy amount. Haha. And yeah, here like the, because it's extern, it's sadly not known like currently, but later it will be known. Okay. Let's just start writing code. What a novel concept. So we have our RDI is added pause. RSI is player. What is our... I think for that I actually will check a Godbolt again, because so we get enemies down here. So we come here like that. It's that bracket? What? Because somewhere I... So yeah, here's just checking against the number. What? Oh, where is this pointing at? L5 and L10, but whatever. Why add 100 to RDX? What? Add 100 to RDX? That is... That is odd. Like, why add 100? Huh. Who knows? Here it does cause player attack, and then we get our other code from earlier, but where do we get the enemies from? Because EAX here is now EAX, that is position. I think that's the position somehow. But not even jump there. Jump to L6. And oh, at 20, that is that is because enemy, like we have 5 enemies, each 20 bytes. So yes, so we iterate over RSI. Okay, inside RSI we have our enemies. Okay. So RSI are the enemies. Then where the hell is... Because here we are also using RSI. Okay, here we are moving RDX. We're moving RDX into enemies. Okay, so it's RDX, right? Let me check. What is RDX? Is just a scratch register. Oh, this IDE looks so what? Interesting. Which one? This one, like Godbolt Compiler Explorer. Let me actually also look at something else real quick. Assembly x86 64 function registers. Aha. Okay. I think I have... Let me... Okay. So, you know what? I will just... put a second one in here. Because why not? Yeah, because... Okay. RDI is the first, this the second, this is RDX is the third. Okay. Yeah, Godbolt. Well, it's, yeah. It's very nice because it gives you like the assembly and also shows you roughly, okay, which code is here what. Like here it's, yeah. This code here checks if basically the for loop is still continuing or not. Yeah, that's why it's putting 100 into RDX and like adding 20 to RSI, and then if it's even, it jumps. I hate that it just does a jump even, because it doesn't account for if somehow it's higher. Because if suddenly RSI is higher than RDX, it would just go on and go on and do horrible things. Nadia. Okay, But yeah, this one is a bit nicer because it tells me here more of the function arguments, yeah. Yeah, when calling a function might be changed and yeah, used freely. Okay. So RDX is our third. RDX is enemies. The thing is, it's all my enemies, like it's a group of enemies. Like it's not just one entity, it's actually an array of entities. I think the stream is choppy. Let me check. Yeah, okay. It just showed me, never mind, just... No, I looked like at the stream quality thing like on YouTube and it showed me, yes, like a yellow warning message. So it might be on my side. That's interesting. It might not just be a you thing actually in this case. Struct anonymous is incomplete. What? Oh, oops, I somehow deleted entity out of here. But yeah, this. I actually can also get rid of this line and then do just enemy amount. Haha. Then I don't need that weird ass thing anymore. Yeah, enemy amount is here and that is extern from standard ASM. Okay. Then... Oh. Actually write the second function. Yeah, YouTube doesn't have enough video data. What the? That is so weird. Like, is it choppy again? This is weird. Okay, I just set my laptop from... That's so simple that it's quite satisfying in a way. What is simple? I like the arguments here. Okay, I want to define, let's just say current pass equal player pass. Let me just reference the table, the code. Okay, yeah. Let me just reference the table. Anywhere where it says use freely might be changed, I just use it. So RCX. Here, move into not RCX, ECX this time. I want RSI. No, because position is 8 bytes. I can do the trick with the quad word again and then RCX. So my whole position is inside of RCX. Ha ha ha. Clever. Let's hope it doesn't bite me in the ass later. But yes. With that I basically have this one now done. This line just in this one line here. Then new pos. So new pos, let's say we define new pos in... Actually, because we do a return new pos, we will define new pos in RAX. Raw. RAX. So our new position will be RAX. it's also, we also use a 60. Do we? Yes, we use a 64-bit register because our position here is 8 bytes, 64 bits. Yes, yes, yes. Okay, that is still good. Let me just get rid of that. Okay. So what we want to do? So first we would want EAX. We wanna calculate the upper bytes first, which is the Y position. Yeah, we wanna calculate the Y position first, then do a arithmetic shift to the right of RAX and 32, which will move EAX into the upper 32 bits of RAX. Okay. Then to EAX we add here our current position. Okay, so what we do first, move into RAX, RCX. Yes. Then added position, which is RDI. So we do RDI. We can... Yeah, no, that is... We do it like that. We move a D word, RDI. We don't move the whole quad word, because otherwise we would... I think it would add weirdly. But I would have to check that in actually a debugger. But yeah, it might add it weirdly. We do it like this. Do these ASM files work with the debugger? I would hope so. That would be amazing. No, it should work. Yeah, it should just that should just work. Okay. Yeah, we have. So we have RCX, our current position, our player position, inside RAX, new position. Then to EAX. No. That's actually... no. Yeah, no, we can't do it like this. We cannot do it like this. Because if we do it like this, we have our current position here, like current position and new position. But when we do this, we also do added position X plus plus this one and this one. But we would then shift X into Y, and that's wrong. So cannot do this. So we need to find another way. What I could try is just do that. I'm gonna try, and I'll see in when I later run the game. Or I'll check and I'll run the game. If something doesn't work, I'll send it through the debugger. So with these two lines done, then we need to check for several things. Compare new position. Oh, okay. What I need to do is compare new position X, which means EAX. In this case, to 1. Jump. If it's less, to return current. What? But I could also do a return void actually, I think. I could do a return void if I change this function to be void, because now I actually use the player pointer here. For now I'll do it like this. Then compare EAX to no, let's put that, let's do move R8 . Ah no, that is because then I would use EAX here, but then and R8. Compare EAX to R8. I don't think that actually works. That would cause an error. So I have to move it into R8D rel grid size, and then sub R8D1, and then compare to R8D and jump grader equal to also this one. Let me actually check again how it's done here, that one. Why 12? Why is it compared to 12? So ESI in this case is RAX minus 1? RAX minus... Okay, that works, but in this case RAX is a memory position, like a memory address, because we are loading the effective address into ESI. But right, we're comparing what? Computes the effective address of the second operand and stores it in its first operand. The source operand is a memory address specified with one of the processor's addressing nodes. The destination operand is a general purpose register. The address has an operand size attributes affect the action instruction as shown in the following table. The operand size attribute of the instruction is determined by the chosen address. Because this load effective address doesn't this... What? And the thing is, RAX is just EA, like... I am so confused by this. I'm just gonna do it my way. Because then I at least understand it a bit more. And then we have to... Okay, So we would be moving. So we have okay, this is new position. Sorry. New pos X 1. Yeah. And then this one, new pos X over grid size -1. I don't like the grid size -1 in this case. That is always so annoying because I always end up like having like a -1 or something somewhere. But yeah, and then I need new position Y, which is inside RAX. So shift logic, arithmetic shift right into R9D, RAX 32. But no, I would shift arithmetic shift left because I want to move the upper 32 bits in RAX down, right? Let me check. Yeah, got build is that's open, yeah. SAL. So okay, SAL documentation. Sorry for the flashbang. Thing is, I need to see the memory addresses. Or like the actual memory that's being changed by SAL. Because these, okay, let's do something weird real quick. I just need to know what it does. I need to see it in front of me what the operation does. So assembly SAR. Let me let me open image, new tab there. And which operation is this now? Shift right, logical shift right. Okay. So removing the upper ones into the lower one. So yes, I want to shift right in this case. And this should also work, I think, because I am right shifting RAX by 32 bits into R9D. I hope this works. Let's try. Not defined. Okay. Oh, okay. Invalid combination of opcode and operands. Shit. So. Okay. Then. Move RAX into R9. Arithmetic shift right R9 by 32 bits. And then I can use R9D as Y. And now compare R9D. Okay. Oh god, new plus Y. Unknown compared to 1. Jump-less return. Current position. God, this is this is so stupid. Okay. At least I now can just do compare R9D to R8D. Jump greater equal return current position. Let me just start something. Okay. Okay. At least this one was easy. Here also. I'm just gonna comment it the way. Okay, then return current position. Okay. Here I continue, but here I just make one return current position. This will just be a return void later. Okay. Okay. Continue. And now I need to check for enemies. This will be fun. I'm just gonna make a new label to separate the code a bit better. What is Corona singing? Oh, wait, Hololive device flow glow? But I mostly hear Watame and Corona. But no, it's not even Corona. What the hell? Okay. It's one of the flow glow girls and Watame. Oh yeah. So check enemies. Now we want a loop. And we have our enemies in RDX. Compare RDX Okay, and I am gonna just check how they did, how it was done in Godbolt again. Because here, yeah. Right, okay, they just... but why move it into RSI? Like, why move RDX into RSI and then 100 on RDX? Oh! Yeah, okay, I understand. Okay, I understand. Okay. Move. No, not RSI, let's just do... I don't need R8 anymore. Let's just move into R8, RDX, and then add RDX 100. Let's close this because now I don't need it anymore with the image I've seen. And then... yeah, because if it reaches this point, because now RDX is 100, which means it is after the last enemy. Because each enemy is an entity, each entity has 20 bytes, and we have enemy amount is 5. Okay, no, I would want something a bit better. I want grids. No, enemy amount. Enemy amount. Times 20 in this case. $20 is sadly not one of like a 2 for 16 32 thing. 32 64 128 256 1024 2048. Yeah. That 20 is not part of that, so I will need a different multiplication here. For that I would want so we saw we have this nice website. Yeah, this website is great. Mole performs an unsigned multiplication of the first operand and the second operand. So, okay. And stores the result in the destination operand. Okay, okay. Here we see first operand and second. So okay. Source operand and this is destination. So into RDX we want this. So mul RDX. No, no, we only have 2 operands, and we need to. Sorry. I need to multiply enemy amount by 20. So we move into RDX 20, then multiply RTX by rel enemy amount. Yes, okay. And then this would basically be, in this current case, plus 100. God, Then we compare R8 with RDX, jump greater or even right, no, then so God, so if it reaches the limit, if it has iterated over all enemies, what it will do is jump. Yeah, jump greater even, return current position. Yes. Okay. No, it won't. It will just... It will just return void. Yeah, no. Oh well, actually return new position, but whatever. It will return new position, but that is overruled. But yeah. No, this doesn't work, but yeah. God! Wow. What did I think doing this? But yeah, but add R8 20. And inside here I will now check for enemies. God, wait. Yes! Oh wow, right, that's why I even do this. Because now the indices, I don't have to look for the indices, because R8 will always want to get for some, no. Because R8 will always be at the correct index because we do plus 20. Yes, oh, thank God. At least this one's easy. Wait. No, yes, because this is player position. Okay. RDA, yeah, right, okay. My brain is starting to get, would a funny happen if you compile it? Yes. Okay. Move R9. No. In this case, I want just R9. Rel enemy amount. R9. Invalid combination of opcode and operands. Mul RDX R9. What? mul source. Multiply RAX and source as unsigned integers. So mul RDX multiplies RX by RDX. Okay. High 64 bits of product, usually 0, go into RDX. Ah, okay, so if it ends up being a 128-bit integer, unsigned integer, the upper ones will be in RDX. So I would have to use like XMM then to like put those in there. But okay. So mul does always RAX. Okay. The thing is, I use RAX for new position, so I will have to find a different one, which is R10. Okay, instead of RX, I will use R10. R10D. R10D. Okay. Because now... And here I will... Now... no. I don't move 20 into RDX, I move 20 into RAX, and then I multiply RAX by that. And that just becomes comment right now. Invalid size operations, size not specified. God. Okay. Let's do R9, because and not specified, it doesn't know, hey, is it 8-bit, 16-bit, 32-bit, 64-bit, because I just multiply with rel enemy amount, and so it doesn't know, do I use REX, EAX? It just gets confused there. So I think we have to specify, let's say here a 64-bit register, run it. Huh? Why is in entity C, in file include from entity C, variable modified group? Ah. Because now, wait. Variable modified group at file scope. File scope, variable modified grid at file scope. What? So this can be dead again, but variable modified group at file scope. So okay, something is wrong with these. Let's try this. No. Oh. God. Variable modified grid at file scope. I think. It doesn't like me doing this. Yeah. Well, not exactly funny, but something happened. This is annoying. Yeah, array sizes at file scope must be compile time constants. It doesn't know it at a compile time, it only knows it at link time. God. Okay, whatever. Where? Whatever. Whatever. Now this compiles again. I'm just gonna have a standard.h and I don't need this anymore. And a standard.asm. A bit annoying, but I can't seem to get around it. Anyway, this now works. Oh god. Why? Anyway, I am ready now to just do stuff. Okay, get back to see. But hey, at least I looked at it now, so not too much, like a bit less fixing for later. Yay. Okay. New position is now R10. But R9 is also being used. Is there another one I could still use? So I'm using RDI, RSI, RDX. is RCX. RCX is the current position. Okay, now I'm getting into the territory of I need... do I have enough registers to do everything? If not, I just have to push some onto the stack and then later pop them off the stack. But I can't forget to pop them off the stack. Otherwise that will cause problems. Okay, I'm using RDI, RSI, RDX, RCX, RAX. Well, okay, RAX is actually... RAX is an... Wait... No, because the result gets saved in RAX, so R9 is free again. But, okay, if R9 is instantly free again, I will... Ah! Oh... God, this is... Okay, I don't wanna have to do like stupid stuff. Okay. Okay, R9D is... New position in general is R10. Okay, let me... Okay. How did I stumble upon this? I don't know. Welcome, Vala? Vala? Vala, I would just say. Welcome. I am writing assembly right now. Learning assembly. Kinda. Frustrating a bit. But yeah. Welcome, welcome. Hope you're doing well. What I'm currently making is kind of just a game inside the terminal. But yeah. And actually, just before I forget that, write this as void entity player gets passed, and here I already pass, okay, the pointers. Then I can get rid of that. Great, okay. Okay, currently I'm just planning to write some of my functions as, yeah. Gonna stay here to support you, just recently started watching some Linux stuff, thinking about switching from Windows. Yes, do that, honestly, do it. I just recently put my main computer actually on Linux. I am on Linux here, like this Fedora with the Gnome desktop environment. I find it nice. It's more kind of like laptop with touchscreen or tablet oriented kind of, but it works for me, and I don't like KDE. But I've been running Linux mainly on my laptop since the end of last year, and like honestly just make the change. It's freeing, honestly. You will not need to get used to some stuff, but it like if you try Linux and then go back to Windows, you're gonna be screaming at Windows, I think. Okay, I was currently figuring out which registers are still available to use, because I think I'm... Wait, no, edit position. RDI is free. I don't need RDI anymore. Yes. Oh, sorry, I hit the microphone. Oh dear. Because yes, RDI I only access once to add it to R10. Okay, great, I can use RDI. Ah. So, the only reason I'm using RDI is to this. God damn it. Because now I still have new position Y inside R9D. I don't need to override it. God damn it. Okay, so R10 is new position, but R10D is new position X and R90 is new position Y. Okay. So now figuring out need to turn the music on my end a bit. Okay. I need to compare. So first, let's do the enemy X position. That is, in this case, yes, R8, but you know, R8 and at R8 I have the X position because it's the first part of it. Okay, I compare. But no, I would need to compare R8 D, I think, to only get the 32 bytes. No, not even that. I need to get to do this. Okay, okay. Do I? Oh, this is because RDX is pointing to all the enemies. It's a pointer to all of them. That is R8. So I need to reference R8. Why do I compare to RDX here? Oh, I completely forget. Add RDX RDI. Right, I completely forget that one. Because I need to... Yes, okay, okay. Okay. Need to dereference R8. But I think only R8D in this case. This is hard. Okay, let me look at what Godbold says. How is it? So yeah, it's also adding 20 each step. And comparing to RDX where it added 100. And then here. Compare EAX to the D word. Right. Like after just doing for like an hour, not doing it for an hour anymore, I completely forgot how to do this again. So the D word at R8 I compare to new position X, which is R10D. Why is this so complicated? Why am I making it so complicated? Okay, the thing is, Yes. Yes. Player pos equal and player pos equal current position. Yes. Okay. That's done with that. Okay, this works good. I can dereference it like this. Good. I can dereference that. Okay. Because I was thinking, can I only dereference like in the second position? But yeah. And jump not equal. That works, right? Yeah, okay, yeah. Jump not equal. Just return void. Great. Because then it moves, the player moves. So then next, compare D word at R8 plus 4. Because now I want to access the Y position of the enemy. And here I do R9D, because that is still new position Y. But doing this all without pushing anything onto the stack feels so satisfying. Like, I'm actually using all the registers I can use without having to push and pop anything off, on, to and off the stack. Yeah, there. Jump, not even return void. I'm thinking about running Linux in a virtual machine first to get used to it. Would you recommend it? Yes. Yes, you can do that. What I do, by the way, I also run Linux and Windows. What I do is I dual boot. For that, you basically, what you do is you create a partition. This, for example, here you have disk utility. This, for example, is my Linux partition. This is my Linux drive, actually. Like I put in another SSD into my computer just to install Linux on it. And then this here, for example, is where Windows lives. This is like the C drive on Windows, and these are just some other storage drives. But yeah, this would be my C drive. And what you can do, you can also do this on Windows. You can resize, actually need to put on my password for it, but yeah, you can resize it. Let's do free space. Yeah, I actually can't do a lot because there is not much space on my C drive right now, but yeah, let's just say like 10 gigabytes. And then if you do that, I'm not gonna do it now, don't want to mess anything up, you would have like another partition where you then can install Linux onto it. But yeah, if you do a virtual machine, it's much easier. Just make sure you have like 5-10 gigabytes of free space. I think 10 or like 20 max, like that should be fine. Windows Linux doesn't take as much, but yeah. Yeah, for example, here I have on my Linux drive with like a lot of it already on it, I have only 10% used of the 470, like, yeah, 51 gigabytes kinda. Well, I didn't know you can split like that. Yes, I can also actually show it to you on Windows. Hello. On Windows it's called Partition Manager. Mine is in German right now. But you just type in partition and it should pop up as the first thing. You just go into it and it should look something like this. For example, here you can actually see I have my C drive, and here I have C, which is only like, well, 200 gigabytes actually, but like installing Windows and everything just takes like some stuff off of it. I have that here, and here is another partition with 766 gigabytes. That is Linux. So I have both of them on the same SSD in the system. Yeah, and D is something else that can be ignored, but yeah. And what you can do here is right click. Yeah, right click. And then this is make the like shrinking the volume or making the volume smaller. It takes a bit because, yeah, like you're working on the active C drive here. But yeah, if you do that, you can basically split it. And then if you install Linux, you gotta make sure you take the correct one. But yeah, here you can see that I can say, for example, 50,000 megabytes smaller, and then I would have another partition here. But I could do the same one. Oh no, here not. Here I can only do volume delete. That would be bad. I would delete all my Linux, like my whole Linux system. But yeah. But yeah, that was a small detour. Right, I also need to do here, I just noticed, player pos equal new pos. Okay. Then, if even not even, we return void. But no, we still we can't return void. We still need to apply the current position to the player position. Return. Wait, no. Then we would return the new. Yeah, no. We return void in this case because we do not want to change it. But no, that's just current position, so these lines are completely irrelevant. I can just do return and return. Yeah, okay. Because those lines would have also caused it to just also continue here, and then it would. Okay. Yeah, only at the end I actually applied the new position to the player position. Yeah, makes sense. Okay. Then after checking that they're even, what I do is I will call player attack. So the thing is now, player attack expects player and target in RDI and RSI. So I have RSI, and I'm actually not rewriting RSI. Yes, because I do need it, because I do know I need it down here. So RSI, but that's the target. God damn it. So RSI needs to become RDI, but this here is RDI. So what I have to do before I move this, but I also no, okay. I can just rewrite this. Okay. So I have my player in RSI. player RSI. Just RSI, yes. And I have my enemy, the current enemy, in R8. Target is R8. Yeah, because those are in the same file, that is completely fine. R8. Yeah, here I check that, here I subtract let me check something. So 12 is my attack. Attack. Yeah, I check if attack and defense are the same. If not, I subtract defense from attack. I move health into this. And then I subtract that from health and I move that back into health. And then I also test it. Return kill or just return. Okay. God, wait, no, R8. R9 is, R9D is new position Y. R9 is nothing. Doing all of this with just the registers that I have. God damn it. Oh. Right, and that I need to check got build again. Because here player attack. Yeah, I just do return, and when I do this call, the next return statement gets to here. Yes. And then at the end of all of this, I would also need a return. Yeah, here it jumps to L5 or L5 return. Here it jumps to L6, which jumps to L11, which jumps to L5, which is a okay. It ends in a return statement. I can't see what you're doing. I can Scheiße! Sorry. Yes, that is. I always forget. God, that's. I hate myself for that. I showed you something early on Windows, and then I forgot to take away the screen capture again. Sorry. God, I hate when I forget stuff like that. Thank you for reminding me. Thank you very much. God, okay. But yeah, I checked and got built. That's like here. It took me a while to notice too. I didn't get too much sleep. I slept like at 2 a.m. and woke up at 7 a.m. Then started stream at 8 a.m. and now streaming for like 2.5 hours. Okay. Just a moment. The sun is shining outside, so I do not need my my lights on in the room. Okay. interesting. You got sun. It's all rain. Yeah, it's a bit of sun. It is quite cloudy, but at least it's bright enough for me to not have the light on inside. Okay, where was I? I was comparing. Right, I was in this compare statement. And if none of that happens, then I call player attack. I updated my those things. Okay, and afterwards I then add 20 to R8 and then I jump to check enemies loop. I jump here because now I added the 20, then I compare if RDX R8 is now over RDX. Yes, okay. Okay. And this loop should be fine. Wait, no. If the position is not the same, it should go back to check enemies loop. Yes. It should go back to check enemies loop, and only then when it's fully and then instead of return void, I do return new pos. So okay. And here I would just, yeah, these ones are just checking for the walls, so these will be just a return void now because I changed the function to be void, so I just return void, which is just red. Okay, so much to think about. Okay. It looks okay. But now I also need to return new position. Here it just returns, and if I attack it returns, but if no enemies happen, I need return new position, and that is the new position is held inside R10, so inside the quadrant of RSI. Move quadrant at RSI. I want to move R10. Yes, okay. Does this compile? It compiles, okay. Cool, very cool. Let me get my terminal. Then Okay, moving still works. Enemies also move. Okay, enemies move because I changed none of that code. Enemies are not losing HP. That's bad. Enemies are not losing HP. I'm losing HP, but the enemies aren't. I'm losing HP because I have not changed the enemy's attack function. Okay. Earlier I think it was still working. Player attack was still working, okay. What changed now is that I'm passing stuff differently. I am still passing the player like this from a pointer. Okay. Let's go over this. I pass in my player. At RS1, I have the attack. I don't need anything else besides player attack. Do I? Yeah. I only need player attack. I can make this even more efficient, but not now. But yeah, I only need player attack. Then I can also get rid of. Oh, am I? Oh, wait. Wait. Am I using RAX for anything? RAX or EAX? Move 20 into RAX here, but yeah, then mul RDI, but no, this needs to be RAX at RAX because yeah, okay. Because I multiply RAX with RDI and the result will be saved in RAX. Move R9 into... Move RAX into R9? Where is RAX being... What? Move RAX into R9. I forgot something here, didn't I? The thing is, I could move. So... Oh, because I have not tried moving into walls. Okay. That's that check. Okay. It's not RAX, it is R10 in this case. Is being moved into R9, then arithmetic shift to the right. Arithmetic right shift. 32. Okay. Wow. Okay. This is something. I could also try GDB. Try to do this with do you have GDB installed? GDB. Yes. Cool. So I have this correct now. Let's just see. see. I will compile, run it, and I will just... Yeah, I cannot run into walls. Okay, but I cannot attack, and now I'm stuck in a corner. Okay. Wait, I do wanna... What I do wanna try is just move left. Okay, it doesn't work. And okay. Yeah, okay, this doesn't work either. I just wanna check if I can walk in the walls. Let's see, thank you. Okay. So it's just that the enemy HP is not being updated. Okay, okay. Then R8 is the current enemy. R8 is the current enemy. We take its defense. And then do this, and yeah. We are moving EDX back into R8, into the position. But yeah, it doesn't do the it doesn't do return kill, it just does return void. But I don't know where it does return void. Okay, then what we do is we run this with GDB. We do a breakpoint at main, then lay next. Yes. Now we have this, and we run, I think. I don't want any that right now. Okay. Step into. We just. I should have exit. Yes, I want to exit, please. Break at main, lay next. Okay, what I actually want, I think, okay, I can break it main. Okay, I source and registers, sure. Source and registers. Then I have a break it main. I run. Can I do break main plus 22? No. Break, okay. 0x400542. Tato? What? Okay. Wait, Y is... What? GDB set breakpoint at address. How to break on... Okay, that seems this message. Okay. Be at 0x400542. Finally, okay. Okay, run and is being debugged. Do you want to start from the beginning? No. Wait. C. Yes. Okay. Okay. Then just step into. Okay. Let me do just lay next. And we have our source here. Step into. Oh no, I'm inside a mem copy, aren't I? Lay next. Step. Huh? Ah, the mem copy is taking a moment apparently. There we go. Wait, no, can't I, break at 0x40077E and then continue. Nice, okay. I need to set another break at 0x40799. Continue. Thank you, GDB. Step it's inside render interface. Oh god. I do want to jump over render interface, please, because that's a lot. Thank you, GTP. God damn it. Okay, get character. No source available. Oopsie. No, fuck it. I will not do it like this. This is way too much effort. There we go. And I have not set a breakpoint. Right, I also actually need to do this. Aha. Player attack, player move. Ah! Global player move. There we go. Okay, because here I can also go into GDB, but I should also, yeah, I have memory view and somewhere I have registers. Rerun, step, let's just step into the breakpoints, mid break. Where do I get registers? Show execution. Somewhere I know I can view the Okay, I can't do layout here. I have memory view here. Okay. Let's see how this goes. The segmentation fault. What? Let me just compile. Don't tell me it's a seg fault. Yeah, it's a seg fault. Okay. It's a seg fault. Okay. Where the hell is the seg fault? So let me just delay next. Visit source and that and just run. There we are at the seg fault. Player move. The first couple lines of player move. Add. Like this one. That is a seg. Why is this a seg fault? Why is this a seg fault? Oh! Yes, makes sense. Okay. So, what's the difference between player, enemies, and added position? The difference is player and enemies are pointers. What is added position not? A pointer. So we cannot dereference something that's not a pointer. Yes. Let's build it again. Let's exit. Let's run it again and the next. And run. No. Amazing. But yeah. It seems to be working as far as I can see for now. What is happening right now is... Oh, it's giving me the... Right, it's giving me the disassembly also here. Neat. Yes. There we go. I do need to compile again. Okay, I still can't attack them, and I can walk through enemies. And walking left makes me walk down. Okay, there are several issues. Several issues. Wait, can I walk through walls? I can walk through the walls. Yeah, if you look at my X position, wait, what? How? Look at my X position when I continue walking here and then one. Oops! Well, this is not memory safe. It accessed memory from somewhere completely different. Okay. Let's fix a couple things. Okay. What I do is GDB be player move. Yes, that's a breakpoint. Great. Then lay next. Sure. Run. Missing RPMs, try. Sure, whatever. I can't select this, of course. I can select it. Okay. No match. Very cool. Yes, please. Okay. Then also quickly do exit here, just run it again. Break, player, move. Lay next. And run it. Okay, great. Enable reboot debug and missing RPMs. Okay, I don't know why it's still telling me that. Well, anyway. Source not available. Makes sense. Okay, then let me get the registers. No, that is the wrong layout. There we go. Now in RAP we have player move, yes. In R10. Wait, let me check. So, player move. Right, okay, here it's AT&T syntax again. So I gotta think differently. But yeah. Remove what we have in add RSI into RCX. Remove RCX into R10. Why am I doing that? Right, I don't need to do that. Okay. I can just move it into R10. I do not need current position. Like, I don't need current position. Because I changed how the function works, so current position is completely irrelevant. Out the window now. Right. Okay, anyway. We then compare R10D. No. R10 contains a freaking big number. Oh. Oh. Okay, do you see this? In RCX, which we got from RSI, we have 7 at the beginning and 7 at the end. That is odd, because like why is it no? Ah, no. Oh, okay. Right. These are the first 8 bytes. Or well, this is byte 0 to 7. The first 8. And then we have the 9th byte as a 7. And then there are just more zeros here, but they're just not being shown. Okay. Okay, I can understand that. Then here we compare R10 with 1. Oh, R10D, so just the lower 8 bytes. Well, right, I'm looking at hex. I'm looking at hexadecimal here. Right, this is hexadecimal. I just remembered, but yeah. Okay, then we continue. R10 RDI. Where do we have RDI? I need to find R. Right, RDI has 1 inside of it, because X is being changed. We are changing on the X-axis. If we were changing on the Y-axis, then it would be hexadecimal as 1 followed by 8 zeros. Okay, that is correct. It's not less than, so we don't jump to return void. Then next we do this is slow disassembly, but we are getting there. Okay, we are moving 8 into wait, we're moving 8 CB. What is CB? But, well, yeah, I have grid size here, which is defined as the like bytes or like byte. It's just a size byte. We move that into R8. So what we want to see now inside of R8. Ah, okay. How does this work again? No symbol B in current context. XB. Okay, no. GDB, C memory. Use the X command to extend memory. Um, somewhere I know yeah, here. Regard the bits of the value as an integer and print the integer in hexadecimal. So, examining memory. Yes, this is what I would want. Alright, let's just do px 0x10f 40f. Wait. Regard the bits of the value. Okay. No, that's completely what something stupid. That just prints me the value, like variable. That is not what I wanted. I want to examine the memory. X to examine the memory. So use X and a few are optional and repeat. No. The repeat is one specifies how much memory. Counting by units U. So I would want I would want 4 bytes, so XW 0x10f 40f. No, like even x0 x10f. Wait, no. 10f 4bof. 10f. But that should be a memory address. Because now if we just go to the next one, we're just gonna subtract that large number from 1. Oh no, we subtract 1 from that, yeah. And then compare that and... Okay, because that's now just wrong. Okay. Let me... because I move the relative, so I can't see the memory there, so... So, well, let's not do this, let's move into R8. Or into R8, into RD remove what's at memory R8. Let me just do quad word. I don't know how wrong this is gonna go, but then let me compile again. Mismatch in operand sizes. Ah, yeah. Okay. Right. Then let's exit, yes. GDB, break, player, move. Lay next, I want registers and assembly. Run. We just do up, just to check different values now. So we move RS, what we have at the location at RSI, because that is a function argument. We move that into R10, which is, yes, our position. That is completely correct. And now we add RDI to R10, which RDI, which is a very funny number. Minus Wait, 1, 3, minus 4 billion. How is that possible? But yes. Because we have moved up, so what? Yes, the y became negative 1. So yeah, the math works out. It's just a little confusing. Then we compare them. We are not setting any flags that would be anything important for us. Now, this one again. Oh wait, x0, x4023e5. xb0x423e5. X423e23e5. Okay, whatever. We're now moving this memory address again into R8. What the heck? Okay, so I need to move it into R8D. But yes, now whatever is at R8 at that memory address, we move it into R8D. That's a segmentation fault. I can't even red exit. Okay, that is a segmentation fault. Then R8D, D word. Okay, it compiles. Let's try that again. Be a player move. Lay next and run. We go up. We have our position there. We have RDI as our correct value there. We basically subtract 1, we add -1, whatever you wanna call it. That works out. And now x0x423e5. I do wanna see what this is. Hex to decimal and the hex number convert. That is confusing. That is very confusing. Because wait, didn't I change? Oh, I did not change this. Right. That is the player move, lay next, etc. here. And then run it. We go up 1. Step. Yes, that's correct. That's all correct. And now we do this. Now we have this address again, which I've seen earlier, but I still don't understand. Then we move whatever is at that address into R8D. And it's a seg fault. Okay. because here we have defined our global grid size defined by 15, yes. And then we have external grid size. Oh, okay. So because it's a byte, okay, we want to move it into R8B. Is it R8B? Let me check. Register table R8B. Yes. Okay, we move it into R8B. Zero extended to 40 bits. Okay, then let's do X or R8. Then we move that there. And we do this. Okay, I did not respect the type. I did not. I didn't do the correct type, so I think that's why. So B player move Linux instead of here. Okay, then run it. And step into it. Correct position, everything fine there. Now R8 gets zeroed. And we move 15 into it. Finally. Yes, that is what I wanted. Okay, because I didn't use the correct types, it just became weird stuff. Let me check something. Sorry, I need to write something to someone. Okay, sorry, I will be right back. Hey, I did not forget to unmute myself and did not forget to put the be right back away. I'm becoming more professional. Okay, but great. In R8 we now have 15. So, how it's gonna continue, it should just now subtract from 1 from R8. Yes, great. Then compare them. And then move R9, R10 into R9. Then we left shift it by 32. And now, see, in R9, now we have 6. And then we compare that to 1. Jump if it's less. If not, we compare it to R8. Nice, jump if it's greater equal. Then we move into RDX. No, RDX into R8. Because now we don't need R8 anymore. Then into EAX we move 14. Then we move whatever that is into RDI. Why are we still at RDX? Okay, I think I know what I'm doing. So then we move that into RDI, which is wrong. Yes, okay. That is completely wrong, because I did not respect the type. RDI, it would be SIL. That is a weird one. So I will also just do X or it just to be sure. So X or that. Right, near then I add RAX to that. Okay. Build finished. Back to here. Breakpoint at player move. Linux and C3 and run it. I go up. I step. Okay. Then I copy RDX to R8, yes. I move 20 into EAX, yeah. I just have that hard coded because I'm not gonna make a size of function in assembly. And or like pass size of nah. That would be too much. And then I XOR RDI. Then I get whatever is at that address into SIL. Huh. Okay, no. I did something wrong. Move move relative grid size into R8B. That worked. Move relative enemy amount into SIL. That didn't work. Like, why? Why did it not work? OX4023E4. X1B0X4023E4. No, that doesn't work. Okay, X3. First format is anders. X1 unsigned byte from 44 5. Oh, okay. Why does it not work? Like, I can do this and I get 5, but why is 5 not in RSI? Like, what? RDI. Okay. No, because I X or RDI instead of R is... Wait. Wait, SIL? SIL is RSI and RDI. What? Wait, no. There must be a mistake. RDL. Okay, someone who wrote the website made a mistake. Wait, from which one did I get this? Yes, here. What the hell? Is there an offer link? No. Can I somehow... I don't know. But yeah. Holy shit, they just... I never noticed it. Okay, it's DIL. Exit, yes. Okay, the documentation I had was wrong. It's like one of the first links on Google, and it's wrong. Holy shit. That's a new one. Okay. The player move. Lay next. Register device and assembly. Run. Up. Step I. Okay. Yeah, I have 20 there, X or RDI, and move that there. I have 5 there. Multiply RDI with that. We have 100 in RX. Very nice. We had 100 to RDX. Yes, okay. Wait, no. Why is RDX currently has something in it? B0. Currently has a 1 and a 10 in it. Yes, okay. That is the position of an enemy. Okay, that's the position of one of the enemies. Okay, okay, got it. Yeah, yeah, that makes sense. Check enemies. We move RDX to R8. Then, wait, can I do X? Yes, okay, great. That $sign and then register works. Good, good, good. Okay. Then move 20 there. X or RDI. Get that into RDI. Multiply RDI with RAX. Okay. The multiply. It's the multiply. It's the mul. What is FIMO? FMO. There's a few data register. Oh, it's for floating points. FMO, yeah, floating points. IMO signed multiply. I don't want that. Compute multiple packed. No, no. Unsigned multiply. Unsigned multiply without affecting flags. Is that maybe the one I want? Performs an unsigned multiplication of the implicit source operands. Okay, those are implicit EDX and RDX, and the specified source operand, third operand. Interesting. It stores low half of the result in the second destination, in the high half. Okay, no, it still stores low and high half. Okay. Yeah, here this one is the problem now, and stores the resultant destination. When destination operand is implied over. And look at it in just the AL, AX, EX, depending on the size of the operand. The source operand is located in a general purpose register or memory location. The action of this instruction dedication of the result depends on the opcode and operand size shown in table 49. Yes, if I can read that. But yeah, it's RDX, RAX. Only if I do explicitly AX. Like if I explicitly have only 16 bytes or 8 bytes. If I have 32 bytes, then RDX is fudge. Okay. So I need to multiply with register or like value of 8 bits. Okay. Multiply then not with RDI, but just with DIL. Because yeah, actually why what else? Then I also don't need to do that. Okay, let's build it again. There. Then let's run it again. breakpoint the player move. Lay next and run. And then step into it. 15 there, now it's 14. Then we move that there and shift that. I still like that. Then we do these things. Okay. We have copied RDX to R8. Now we move 14 hex, hex 14 into EAX. Why EAX? I don't know. I could just do AL or... But yeah. We put that into RDI. Then we multiply RDI and RX. Well, AL and DIL in this case. We still get our 100 and RDX is not touched. Then we add RX to RDX. Nice. Then we compare RDX to R8. If it's greater even, return true. Okay. Oh! This is pain. But I think after, like, if I can do this, then I will be able to do much more and like more quickly. So like this is the growing pains. But this is the growing pains of it. Okay, let's just check if everything here looks fine. I didn't run into an enemy. Ah, no. Okay, it's an infinite loop. No. Start from the beginning. No. Just C. Continue. Yes. Infinite loop. Right. Okay, because we are moving way too quickly back up to here. First, I need to actually add. I need to... So then just make this, add 2 to this, because then it jumps over player attack, and just does, exit this one. Okay, okay. Okay, no, that's not it. Let's run it again. The player move here and run it, and I just go right. Let's run it again until no. Let's continue until I. Okay. Now I want in. Step into. Let's step in. We're at position 6-9. Nice. We compare that. Yeah. We X or R8. this, all of that. Great. Then we move RDX into R8. Then there 20. We now have in R. What? Wait, what? Wait, what? Why is 5 in R9 and not in... Oh. But why is 5 in R9? Why is 5 in R9? Oh, that's the that's position. Right, that's our position. But, right, okay, that's our position. I read our position as 6-9. It's 5-9 actually. Got it. Okay. Okay. But if we look at RDI, actually the top half of it is yeah. But the multiplication still worked out. Hey! Okay. Then we move that, we compare. R8 to RDX, yes. Return. Wait. Ah, yes. Then the value in R10D and R8 gives us a carry flag and a signed flag, which means we are negative. Wait, not even. Yeah, okay. Then we add 20 to R8. Jump. Wait, what? Wait, what? Wait, let me check. What? I'm an idiot. I thought it said jump label, not... I thought JL was jump label, not jump less. My fault. Okay, well, recompile. Let's run it again. B player move. Linux. At some point I should just make like a... Like I always do this, like always set up. First have to set up everything. Run, yes, I move down, then I continue and move right. And then step I. Okay, we're at 8.7, so R9 should be... well, I thought we were at 8.7. I thought we were at position 8.7. Oh yeah, no, that's the new position, right? Okay, that's the new position, and... Yeah, okay, all good. But 8.7, no, it's 9.6? Wait, no, I need to run this again. So we are at 7.7, now we should be at 8.7. Like if I just step into it. Wait, yes, okay. We're at 7.7 and we add that to it. Okay. Yes, that's 8.7. Good. And then R9 should have 7 in it, right? Yeah, we have 7, 8, then we do that, and then it has 7. Yes, yes. Okay. That's correct. Then continue, continue. Okay. Move up. Then we step into. So we're at 710. But I'm moving up, so it will be 810. So R10 will be. Oh no, I'm moving up. I'm moving up, so it's negative. Yes, yes, that is correct. Then 6 will be in R9. Okay, then we go on to the enemies. Amazing, RDI just works out. R8 and RDX are not... yeah, that is 100 apart at the moment. Then compare R8 X 8 unsigned bytes at R10 D. No, that's just that's just that position at R8. 4 and 10. Okay, so not my position. That one is actually a bit more to the left of me. Yeah. Okay. Yeah, it wasn't even, so now it adds 20 to this. And then it jumps back up there. Compares, it's not even yet. It has the carry flag set, not the 0 flag. Then we go here again. Oh. So I do want to see X8UB at R8. That is 10 and 6. And 6 and A are in R10. But yeah, that works. Okay. Let's step into player attack. Let's see the actual thing. So, into EAX, we now move something RSI. Right now, because I did a call, some registers have changed. Well, whatever, it should be fine. Okay. So, 2 is in there, move then that one into... Yeah, offset by 6, so we take what's at R8, offset it by 16, and move it into ECX. At 0, that is correct. Then we compare, it's not less, then we do this, we subtract nothing. Then we move whatever we have at R8, offset by 8, into EDX, which is 3. Then we subtract EAX from EDX, and we move EDX back into R8 offset by 8. So what I actually want now is 40 unsigned bytes at R8. Wait, no, not 40, 20. I need 20 unsigned bytes at R8. Yeah. Okay, so the first one, the first two there are position. Then we have HP, attack and defense. And now the HP is 1. Great, okay. Then we continue, we test, it's not a return kill, so we just return. We check over the rest of the enemies, but nothing happens. Okay. Right, why was it over so quick? Return. Why are we at return new position now? Move R10 into whatever is at RSI. Okay. I want X 20 UB. Or 4 UD. No. 5 UD. At RSI. That's just 10.6. X 20 UB at RSI. Okay, no, that is correct. That's my position. Yeah, okay, so it has written my new position and everything. And okay, step. I'm now at main 54. Yeah. No, just more stuff at main, but yeah. Then C, continue. Why? Ah. Okay. Yeah, okay. Oh, okay. This is so complicated, but we're getting there. The thing is, what's happening after this, we return new position. After check enemies loop is done, we return new position. That is wrong. What we need to do is, after an attack has happened, we abandon the loop and just return void. Like we do here, return void. So we actually don't call this function, we just jump to it. So because when we do that, when we call a function, we the next return would set us back after this one, so we would be here. But we don't want that, because then we continue the loop and then we do return new position. What we do... What we do is we just say return from everything here. I don't even need global player move. I just need a global player attack. Let's just keep that. Let's just keep that. If I ever, for some reason, do player attack. But, no, even then it wouldn't work because of this. Yeah, it wouldn't work because of this, because R's I and R8. So I would need to find some. But yeah, the thing is, if the thing is, I could set a flag. What I could do is set a flag and look for that flag, or another thing I could do is I check and after I've called this, I check enemy position. Nah, let's just always move and always attack. Will make it a bit easier, but yeah, that means after an attack, yeah. Okay, let's do that. Okay. Okay, whatever. Continue. Okay. Here we are again. Our player is moving. We're at position 5-9, or we wanna move to position 5-9. We check if an enemy is at position 5-9. Currently there doesn't... Oh, we got one. Was the second one already? Nice. Okay. What we do then? We get that in the EX, there, check, okay. We subtract. We move. And the index 3, the HP, we subtracted, we move that back there. We test, we return void, and we are back into main. Great. Yes, good. Anyway, I just wanna now see. Okay, somehow when going left, I think I made a mistake somewhere, because when I type D, okay, no, but the thing is, when I type D, I go bottom left. Why is that? I have like everything works besides going bottom left. Okay. Let's see what happens. GDB be player move. Next and run. Okay, D. Step into it. We're at 7-7. And we add RDI to R10. So X 20 UB at RDI. Okay. Okay. Ah, no, it's a -1. Right. Okay, it's -1. Yeah, that makes sense. but it doesn't make sense there. Because it goes from 7.7 to 8.6. God damn it. Why is that? Why is that? It's because it's negative. Okay. What I need to do then? It's negative, but then why when I press W it's fine? Like when I go up it's fine. But when I go like I go up, it's fine, but up is also minus. If you can look at the Y in the top left, like up is also minus. It's up, control L. Then RDI is on. Okay, if I move up, RDI is only Fs in the first half of the, in the upper half of the register. The lower half of the register is all zeros. Okay. But if I go the other direction, What if I pass the pointer to A? Add. Let's just work with pointers. Why don't we? Maybe that's also the issue, because I'm handling it as a pointer, but something else behind the scenes is handling it differently. Let's see. Let's go to player move, edit position becomes a pointer. Player move becomes a pointer. Yeah. I know, yeah, edit position becomes a pointer. And then here, edit position will also become a pointer, which means I now do want the keyword that lives at RDI. Yes, okay. And besides that, RDI is never used again. Oh, build is F9. No, build is not F9. Oh, it's control F9. Just make it F10. Okay, yeah, control F9 is build, but F10 is also build. Because like F9 is debugging, not building. F10, Shift F10 is... Alright, brain. Shift F10 is build and run, and F10 is just gonna be build. Yeah. That makes more sense. Okay, exit, yes. Run it again. The player move. Play next. Then run. No. Let's see. Let's step into it. So, let's see. X8UB that live at RDI. Hey, it's only minus in the first half of it. Very nice. So then, Steppy and... Okay. We are encountering the same issue. Continue. Yeah. If I now move up, X8 UB at RDI. Continue. Let's just do right. X8 UB at RDI. Yeah, that's just the one. Continue and down. X8 UB at RDI is also just the one. That is confusing. It's the way I apply it, something about that, because I just do add a keyword, add whatever is there. Okay. Okay, so add. So we move the current position into R10. To R10D, we add D word at RDI. Then we also move into R9, R10, and then at R9. No, we before that. We SAR R9 32, then add to R9D D word at RDI +4. Not much changed actually, but it should work much better now. So I know I can just exit and just run it. I cannot move anymore. What? Why can I not move anymore? Okay, so what? So current position is 7-7. Okay. X8 UBI at RDI. Okay. Yeah, I do that. The thing is, it will just add the 0 to it, right? What? Huh? 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 Okay. What? X8 UB at RSI. That's my position. That's my position. Yeah, that's 7-7. And what the... Why is it suddenly just 8? Oh, it overrides the whole thing. Okay. So I do this and it should be fine. Exit, yes, run it again. B, player move. Okay. Run. Step into. Okay, there we have our 7-7. R9, R10 are both nice. And let's also just, like, let's just confirm. At RDI we have, okay, that one, I don't like that one, but sure. And then at RSI we have our 7-7. Okay. Then add. We get 6. Okay. That is our Y position. That is because I pressed D. So that is expected. Then we shift that. We offset RDI. And that stays 7. Correct. Everything looking good. Yeah. That looks... Return new position move. R10. Oh, okay. Good thing I went through this. Because here... Move... We want D word. R10D. And then move... D word RSI plus 4 R9D. That's important. That is very important. Otherwise, we only move on one axis. But yeah, splitting the axis actually earlier makes it much easier. Because then I don't have to think of R10 as new position, I can think of R10 as new position Y. Like of Y and then R9 is just X. That's much easier to think about, yeah. That is very nice. Then exit. Yes, and build and just run, and I can... Okay, nice, everything works, I can't walk out of the map. Cool. Great. Finally, after 4.5 hours, I have translated another function into assembly. Okay. God damn it. But should I just now already... uint 1 to 28. Ah, yes. Because I want a uint 128. I actually need this one again. Let's just replace all the ints, because now entity is size 5. 4 times as little. And group entity is now this. Instead of, what was it before? I get, see, group 80. Like, nice. Player, that's just entity player, yeah. Okay, I'm happy about that. Now I do need to update my assembly again, because now I don't do double words anymore, otherwise I would get more than... If I now did a double word, like, let's say here, or a quad word, RSI, I would get 8 bytes, which would be more than is inside of entity. Which is funny, but would be annoying. Okay. Let's see, what are the types? So, either I would want a word for, let's say, position, or I want just a byte for, like, one thing. So, if I want position, I take a byte, and if I just want one thing, if I want the whole position, I take a word, and here I take a byte. Then I also need to adjust every... Okay, because this is now just a word, we need the... So, R10W, yeah. And this is just a byte, so R10B. R10W shifted and then R10B. Like suddenly is so much smaller, like things. Like let me check. Alice CMake, it's 27 kilobytes. Let's see what it's like with the with 32-bit integers. I wanna see what the size is with less. It's not gonna be like that much different because there's not that much in the code, but yeah. So if R10B then XOR R8, that's already a byte value there. R10B, I can keep using byte values here. It's so funny, just I'm using byte values instead of like double values. I know, it just amuses me. Okay. Okay, then... Because R8B here is just grid size, yes. So, check enemies. Move RDX into R8. RDX is the pointer to the enemies, yes. Move 20 into RAX, which is crazy. But we do move it into RAX because it then gets multiplied with that and added back here. So let RAX is just fine in that situation. Then we compare with not the word at R8, we compare with byte at R8. Also here +1, not +4 bytes. And here also +1 byte and we compare with I know, I find it too funny. And return new position, we do bytes. Change it also to 1 byte. And R8 here never gets used in a way with like okay, good. Then here. Because entity is now just so 0, 1. That is 2. It's 3. The third byte. I want the text, so I do RSI. So I do byte here and EAX. EAX byte register is, how's that called? Right, yeah. AH or AL. Yeah, let's do AL. Then CL. I want a byte. And that is 4. And compare AL and CL. Sub these then into DL move byte R8 +3. I still find it so funny. Right, +3. Is it at the third byte? The R8 is position is X, R8 +1. What was it before? Was it 12? No, 8. Yeah. No, it's just 2. Yeah. The AL, DL, and here we return a word into R8 instead of a quad word. No, this is not gonna change much, honestly. Can I? Oh, it compiled. Hey. It's still 27 kilobytes. What did I expect? Honestly, what did I expect? Oh dear. Is it just playing the same songs like on the loop? I could swear I've heard this one today already. No, let's just get some different music. Like, I think several songs I've heard already today. Renegade. This one's nice. Okay. Then I do just want something's wrong. Something's very wrong. Okay, I do set them to 0 here again, so what suddenly went wrong? What? So a word RSI we put into that. Like, okay, no, I'm just gonna GDB the player move lay next run okay, it's now 7-7. Then to R10B we add whatever is at RDI. So X 4UB at RDI. Yeah, that makes sense. Or no, 5UB at RSI. That should be all. Yeah. Okay. Step I. Let's see what happens. Yes. Okay. That's R10, but it doesn't override that. And then we left shift R9 and R9 does. Oh, because I left shift by 32 still. That's why it does not. Okay, no, I can do this better. I can do this better. Okay. Where I'm gonna do it is I'm just gonna do a byte. I'm just gonna do it byte like from the start. Byte RSI plus 4, then I also don't need to do any. Wait. Anyway. Yeah, no. Like this, then I don't need to do any weird like shifting, and it's one thing less. I do need 4 memory accesses, I think, instead of. But yeah, I'm fine with that. The CPU can cache. I'm trusting the caching. Okay, run it again. Okay, I can walk inside of the enemies. I'm getting attacked by the enemies. I can attack enemies, but only under certain conditions. Okay, interesting. I would take a short break again, and then I'll be right back and I'll figure that one out. Okay, I am back and I also removed the BRB and I muted. Hey! Okay, so why are enemies running away from me? I had that issue before. I had that issue before. Let's check. It's the enemies move function, so it's actually nothing to do. It's something to do with me changing to uint8. Okay. Declaration assignment can be joined. Yeah. Okay, enemy move. Okay, what is going on here? Redundant else keyword? Why is this suddenly redundant? Oh, it's... because it's uint. Narrowing conversion from int to signed int is implementation defined. But how am I narrowing from int to int8? Where am I narrowing to int8? Like, player also uses position, it uses standard. Heh? How am I... What? What's that error about? Okay, assign char. Narrowing conversion from int to signed type int8. What? Eh? What do you mean? Yeah, that one is... Is there a different random that doesn't give me an unsigned int? Or what is... Return random integer between rand max, yeah. Return non-negative. Is there somewhere I can get a... can I get... this is a long int. I would like... Is it defined up here somewhere? And max... okay, it's... That's floats. I don't care about floats. String too long. God. Is there? I can just do int 8. No int 8 random. Int 8 C int 8 random. Yeah, I would have to. Wouldn't I? Hagem Mohammed, what are you working on? Working on a small game. It's a game you can play in your terminal. Yeah, the player character is the @ and the X's are enemies. Currently I'm having an issue where enemies are running away from me. So, yeah. What I did was I changed... what did I do? Just one day, so I gotta hide this real quick. Okay, there we go. And I just opened something that shouldn't show. Yeah. And it's all written in C, and then also some assembly, x86 or 64 assembly. I wrote this part today, and that took me several hours because I'm not good at assembly. But yeah, currently I also had before like position as like just int, but now I changed it to int8, but actually I need it as uint8. I need position as uint8 and no, wait, as int8, yeah, because I need it signed. U is unsigned. Yeah, so signed because position can be negative. Yeah. Yeah, currently figuring some stuff out. Like this warning, for example, which doesn't make much sense. But yeah. Because everything is struct position, which works with int8. But it tells me narrowing conversion, like it converts an int to a type int8. And I don't understand why. Maybe I just... Maybe I just restart CLion. Okay. Let's just load everything.
1, 2, 3, 4.
Nope, it still tells me this error. Or warning. Well, I'm not narrowing int to int8 anywhere, so that is fine. So this one is confusing me because I am shifting the 32-bit int. Oh, well, not 32. Looks fun, bro. I'm gonna grab something to eat and watch you while eating. Can you lower the music a bit? I can't hear it clearly. Oh, sure, yeah. I didn't know. I had asked earlier, but no one had said anything. How's this volume right now? Like, how's the volume like right now overall? It should, the music should be a bit louder, quieter, that way around. Okay, I don't want to shift it by 32, that is 32 bits. Right, you know what, I will deal with this when I need to. I will deal with this when I have to. Okay. Yeah, I did the same thing here, but this one I don't understand, but that should be fine, but okay. So let's just quickly build it again. Okay, enemies are following me again, but I... Okay, something isn't working. The collision detection is having issues. Why is collision detection having issues? This here. Ah, because R10, no, R10 is... Okay, I need to rethink Yeah, no, let's have R9 as that and R10. Yeah. Okay, R9 is X, R10 is Y. Then RDI is also just the same in that. Then compare if R9 is over 1. Compare if R9 is under grid size. Okay, those are done. Then here, I want R9, R10 to be compared to those. Okay, new position, that is correct. And then up here I'm not using position, I'm just changing position of R8, which is the enemy. Okay. I can just walk through enemies when I walk downwards, also when I walk upwards. This is so confusing. Why is that possible? Why can't it just walk through? Let's check it with GDB. B player move and run. Okay. Step into, then let's see. X5 unsight binds at RSI. That should be here. That looks good. I can move past this and then check 5 unsight bytes at R8. Nope, that's not yet the correct enemy. Okay. Then X5 unsight binds at R8 now. Nope, that's also not the correct one. How about now? Why is... What? How is... What? No. Huh? R8 and RTX. No. That is still... Oh! That's the problem when you just hard code values. Oh god. Yeah. Now it works. Okay. That's what I was doing, because the size of entity has changed, but I was still using 20 bytes here instead of 5 bytes. So yeah, several things just weren't making sense. Okay. Good that that's taken care of. I need to check on something. Okay. Can I... God. Oh, Hakim, you joined the Discord. Welcome, welcome. Nice to also have you there. I need to really quickly check something on my phone. Yeah. Before I woke up today, I didn't have time to check yet. Okay, looks fine. Okay. Then I need to... Okay. There we have the terminal back. There was just some stuff I needed. I had a script running in the background and I just need to check on that. How that was doing. Okay, everything is working again. Then I could start trying to... IDE error occurred? What? Okay. I could make a new file, enemy.asm. .asm, yeah. Just make sure I have this. Yeah, right. This one. Yeah, I actually don't have to malloc anymore. That is... Like, I don't need to do malloc anymore. Wait, okay, let me check stuff. Because entity, group, entity. Where do I use group entity? Here. Call it enemies. The thing is, I just need to do this now, right? Might not be initialized. If I have it like this, it's initialized, but it's not even initialized then. And I'm initializing them here. Okay. Gotta check out the community. Been looking for people who are into coding and geek out on coding stuff. Nice, nice. Yeah, no, I understand. I understand that. I like just I'm at several like Discord servers where I just am there like for the programming channels. What? Build finished. Okay. Let's see. Let's just run it. There we go. That is our segmentation fault. Program received signal segmentation fault. Yes, on this line here. Okay. And that is probably because this is returning an integer. So, what if I cast it to int 8? Let's see if that works. Int fast 8? What is that? Int fast 8 is also assigned char. But why fast? What? Okay, no, I'm just gonna do int 8. Let's see, let's... Expected expression before. Okay. I can't just cast it to that. Okay. Int 8. Right. Yeah, x equal rand. X, y. Narrowing int to int 8. How would I do this? I would take this and C right shift. Okay. And C left shift, right shift operator is a binary that I use to shift bits either left or right of the first operand. Specified by a second. Allowing efficient data manipulation. This article. So A is 21. Well, it doesn't matter, I think, how I can just shift it in one direction by 24. That should work, like... That would make it, yeah, see. that is still why is that still? Like, this should work, right? Why is it a seg fault? Why is it a seg fault in this case? Huh. That is... Ah, God, okay, let me just... God, God, I just want a quick randomize function. Okay, here's some... Just a seed random. Okay, no, option initialize a random number generator to use state buffer set with link state elements heated with seed option use 8, 16, there is less than 8 will cause an error and values greater than 256 will be rounded down. Ugh. Nah, this is okay, this will just be a weird this will be a weird one, but whatever. We take I times 81 and add 49. And then I times 17 plus 91. This will be a weird RNG generation, but whatever. But fuck you. Like, oh, what, really now? Really? Like, if I run this, will result in a sec fault? Like, I already give it that type. Like, okay, will this result in a sec fault? No, expected expression before. Oh, because... But... Why? Why? Why though? Ah, God, Like, I want a signed integer that's just random, please. And I narrowing from... Like, really? It isn't int 8. What more do you want? Like, what the heck? I think I'm slowly getting to the point where my brain is just slowing down after 5 hours now. So I kinda need to... I'm kinda more quiet now, sorry about that. But yeah. Did I move this? No, okay, I can't move this weird. Okay, it seems like I still need to do malloc, but yeah. Are you kidding me? Are you really kidding me? It's because I forgot the malloc. Yeah, it's because I forgot the malloc. Okay, it doesn't work in here, but yeah, whatever. I hate this. I did need the malloc. Well, whatever. Ugh. At least it works. Can actually look at rent again. Oh, it's external. Wow. No, whatever. Does it still run? That's the question. Yeah. Okay. Okay. Yeah, no, I think I'm just gonna leave it here for today because my brain is slowly shutting down and it's probably not entertaining anymore if I just mumble before myself. So I will just leave it here for now. I will stream next week again. Sunday, yes. I don't know about Saturday yet though, sadly. But yeah. I'm gonna stream again next week, again at 8 AM, or like next week and then -5 hours, kind of that time. But yeah. And thank you guys for joining and I'll see you next time.